यहाँ पे
चलो Yeah, that's good. I think you'll go first. Okay, here first speaker. So, yes. You get the number.
that make it easy to do the video conferencing. Is there a Wi-Fi it's called in Chandalagur? Password go and you can join this. Meeting ID is 595 Yes, it's not correct your audio. Let me tell you. And then you can share your screen and do. Share my. Yeah, I think if you do it, desktop. Can you do the forward? Just it. Just check whether
It looks like my VPN is connected. I just kept the demo. We have a recording of it. We have a network, right? Your network or network?
How recorded? It's already recorded. Okay. The video is being recorded.
It's already recorded.
Oh, it's already live streamed. So next time also it's recorded and then share it. Now we get out in the
Good morning, guys. Thanks for coming over for this long weekend. I was a long weekend. It's good that down here. So this is nice meetup between doctor and Kubernetes meetup. So I have considered doctor group and we have first general Kubernetes meetup. So let's get going.
So welcome back to
Some of the laptop
so
is
my name is
should be mute, sir.
I'm from SAP. I'm working there as a senior developer in the container ecosystem team. So our team's goal is to leverage container technologies for the developers and to make a happy part of production in a very high level sense. Right. So about me, moving on. So this is about Congo. So what we do, we are travel expense and with expense management company basically. So we are industry leaders for the last 20 years. We have a large number of clients, around 45 million, very good number currently we are touching around 80 million. So quite a large scale we have. We got acquired by SAP in 2014 and have been growing ever since at a very fast rate. That's the way we manage this. The numbers are not complete, but by 2018 we're trying to touch $2 billion in revenue. And that actually called for a better software delivery system. And what better than Kubernetes in this current environment, where you can have all these features built in to your infrastructure. So to begin, so we started our Kubernetes journey around 1 year back. This was a phase one instance in which we tried to educate the public, try to get a scene around a requirement gathering around how Kubernetes will work in our own system. So this was 1 year back, and this is what the structure looks like. So, this is a basic CAC setup. We have board around the whole architecture. This is what CAC setup currently looks like. So we use GitHub as a GitHub platform, and connect to Jenkins. The Jenkins 2.0 plus, which part has better. So the character is we write our own workflows. So specific to the technology that we are using, say Java, the language we use, Java, Golang, or even deployment methods such as help, packaging methods, it can be argued. So all those methods are built into a workflow that we wrote ourselves and we deploy onto this built-in environment. Now we use managed frameworks for on Kubernetes platform, where we use more as a technology. But most of our workloads currently is on VMs rather than being on the cloud. So AWS is it visible from the back? I'm not sure. It's visible. Isn't it? Okay. So we we are using Kubernetes whole stack, Kubernetes being the container repository and Tectonic being the managed Kubernetes service. But most of our workloads is in Teams. Also, we are collaborating in 6 different regions around the world. Starting with China, 3 different regions in EU, 2 different regions in US. So that makes a challenge to get to those cluster jurisdiction. So due to GDPR and other compliances, we need to have different a second layer of Jenkins in all those regions so that we can easily deploy to those maintaining compliance. Now, leveraging that sense, what we did is we decoupled health from this layer and based it on the deployment. So, and obviously workflows around it so that developers could easily deploy on the Tectonic environments. This worked okay. The first phase of developers were very happy. Mostly in the sense that they were hackers. They wanted to know what Kubernetes works like, how to write manifests around it, how to write help charts around it. So that helped a lot to them. So they were having an end-to-end, not only control, but end-to-end knowledge about how, where the software has been shipped, how it has been shipped, how can they modify it. But the second phase of developers don't like to learn so much. I'm not complaining, but there are other human nature involved somewhere. So they were not very involved in how to like how the things works underneath. But they wanted a simpler way to get into it. For them, Helm chart was a very difficult task to write or a overhead around. I'll come to those latest other lessons learned from this architecture. Another piece that you can see is called Skipper. This is open source by us. So I can go to GitHub Conquer and find it. So what this does is it adds a layer of grid to the imperative nature of Kubernetes. So Kubernetes appears an imperative by nature. It doesn't have grid kind of operation where rather you say, okay, run 3 copies of this application, it runs 3 copies. You don't say, okay, add this, remove this, delete this, which is more of a declarative sense of language. So what Skipper does is not only adds a declarative sense to the things, but also skips this jurisdictional boundaries that they have. So this was a very good tool for some guys, but again, we need some kind of an audit, some kind of history maintained around deployments, like who deployed when and how. This was more like pushing from a laptop. You can say you're on a vacation, nobody knows how did you get the code out there. So we skipped this, but we again made it open source because it's a very good tool to just to maybe integrate into GitHub or something like Jenkins and use it. So this is an open source from our side. Also, we are collecting different metrics. Also, apart from this, we have other metrics code. We use console for service discovery outside the clusters. We have Vault as a secret manager. So those are not included because this is more of a CI/CD job rather than how we maintain our Kubernetes cluster. Right. Moving forward. So this is our scale. In the current way. So we have 15 different clusters in 6 different geolocations, maintaining around 7,500 different pods and numbers. We have around 3 nodes, and this, apart from this, everything else is just 5% of the workload currently. So, this, as I said, this was the first phase. We're trying to adopt Kubernetes into Container. So we ran only 5% of the workload. 5% not only because we wanted this to be a trial, but also because most of our code base was monolith to start. Currently, there is a big story going around in our organization where we're trying to break this monolith into microservices and host it around the world. So that is the thing. So we have around 30 teams to be onboarded currently. So you can understand if this is 5% just by linear number, it will be more than that. Yes.
Yeah, couple of questions. 15 clusters, 15 Kubernetes clusters.
15 Kubernetes clusters.
So now 92 nodes are included among 15.
The total number of nodes if we add up all the clusters. So each cluster, one of the clusters
is something like 15 or 20 nodes.
Yeah, that's an average. If you put an average.
And then here are cores and nodes related. If you see that that also comes into 50 to 20 cores per Right, but it's not average if you have an average table, but it's not like that. So one of our clusters is just a QA cluster, so that contains around 2,000 to 3,000. The rest are product. So that is so this is average that only 15 to 20 nodes will be not like proper utilization of the nodes or how this is nearly 80% utilized. With that for 80% utilization, you need 290 nodes for right. So this is our use cases can be different with other organizations. We do DR by right. So because you can see the numbers are high, so we have a DR set. We do have a DR set.
So how these clusters interact with each other or they don't interact? If it's cluster, are they connected to each other or
no? Within jurisdiction, just like I said, these are representing different jurisdictions. Say this is Seattle, this is Paris, this is China. You can't talk between them. So you can't talk between them. You can talk within the jurisdiction. Say within Europe you have Paris and you have say Amsterdam. You can talk between them. That is allowed. But you can't talk amongst.
so they are not in same CNI network?
No.
So we just here in the picture there are three clusters.
Actually 3 clusters.
And if they want to go, they will go to external to the cluster and then
You can go through console maybe, but that is not. Yeah, so thing is like within a jurisdiction you can have a console server, where you can host your services endpoints. And the other cluster, there is a Paris cluster, there is Amsterdam cluster, there is a console server. Now the Paris cluster wants to talk to the Amsterdam cluster. What you do is you have a console server in between. So the console server has all the service endpoints. There you can go and talk to it. This is within the jurisdiction. Outside you can't.
would you like to say about how masters are there? Just single master?
So we maintain 3 masters per cluster. 3 masters. Yeah. Any other questions?
Okay.
You can decide or take it now, take it later. It's just for you.
Will you use the Kubernetes federation or how?
No federation. No federation. Right.
How they are interacting with?
Console server. So the main thing, console is a service discovery tool given by HashiCorp. So basically, the thing that you want to interact with is another server, another service in another server. So what the service does is it posts this endpoint into this console server. And the console server is centralized for that jurisdiction. From there, they can connect. Okay, moving forward, lessons learned from this experience. So the first is why should developer write Kubernetes manifest? It is not their job to do it. A Helm chart may be simple for you as you see the examples on net, but as the application grows complex, your Helm chart also gets complex. Complexity gets added. So this is one takeaway that we got. So this is not only about the CI/CD but also at large about running our Kubernetes clusters. So push versus pull model, I have a demo on it. I will talk about it. Large clusters versus multiple small clusters. So with large clusters comes the overhead of operations of monolith, the cluster being a monolith. So something like a Rook. So Rook currently is a beta. It also covers the persistent storage part. So it is a beta under CNCF project, newly sandbox basically. So it supports up to 7 nodes. And one of our QA clusters were running it on 15 nodes. So that was a direct result of having large clusters. So it's always advisable to have multiple small clusters rather than managing a very large cluster, because operation overload will get you at the end. Plus the right side. So Kubernetes moves very fast. So over the last year, we have set several different releases, and we had several different clusters moving forward. So moving workloads from one cluster to the other was one hassle, in which we need to involve different teams due to our model of CI/CD. So we did have an improvement. Also, if possible, I'll show around what we did, a tool that we created to get around that. Platform standardization. So to start with, we allowed users to use any container they like. Not any in the sense that any vulnerable container, but something like they're free to use either Alpine They're free to use distroless. They're free to use any other type of base containers they like. We are not recommending anything from our side. So this led to a mess in the platform standardization part. So we had different types of containers around the whole spectrum. So going forward, we decided that we will be providing the base containers at least. So that will ensure there's a platform standardization. So these are all these are all the points that actually feed it back to our phase 2 project. Load balancing. So this is one experience from using the Nginx Ingress, which is open sourced, openly available outside. So this is an experience from our side using it. So one thing is that it fails more than often. So say if I have a 500 to every 600 requests, there will be one or two 5x's. And that is more than, very concerning for us, at least in the production clusters. The reason behind it is the way it is made. So Nginx Ingress that we get is more of a controller which looks for Nginx objects, and based on that updates a Nginx file, Nginx conf file. Now the problem around is that as new deployments happen, we need to reload that file, and that leads to drop of packet around in the network, and this causes 5xx. And though it is very less, which is 1 to 2, but moving forward it will be a very big issue as we tend to take 100% of the workloads into our Kubernetes management. So that is one thing. Second thing is we had an internal FI cluster, so we wrote an FIAK around it. So hardware load balancers are difficult to integrate, but still we went ahead, wrote a tool around it. But again, it was more of a workaround to get our customers to use our product in the VMs rather than which is more readily available in the AWS counterpart. Personal storage I talked about is not very much matured yet. If you are in the cloud, it is better to use some kind of a managed product. If you're using a DB managed, some kind of managed product like RDS or Elastic Caching in case of AWS. Cluster operation. So there are two major points that I can remember. One is STD maintenance, if you're using STD as a database. So there's a very good documentation around it. You can go through it. That is a must going forward because it will some other time will come back to you and continue. So STD maintenance is one thing that you should look forward to. Second thing is the node degradation. So Kubernetes nodes are again objects around things. So you need to have checks around crash tubing faults. So how many? So if it is more than 15%, that is our threshold, then the node is degraded to some level. Though Kubernetes, in theory, if a node has degraded, should evict those pods and run it into a different node, but that doesn't happen completely. So you will have certain pods always running crash tubing inside that node. So to avoid that, please have some kind of check inside of your nodes. So for us, it is a Prometheus check, which looks around for 15% crash tubing pods, and if there is, it is notified straight away. So that is one thing. There are more things like broken pods. So if you're running a QA cluster, people will deploy and forget about it. So yeah, it is crash tubing. So it will cause huge number of events within your cluster. And not only it just degrades your monitoring performance. For us, it was Prometheus. So Prometheus takes in this event. Okay, there are more crash tubes, and it will cause a lot of clutter. So look for broken pods and fix them right away if possible, or have some kind of restriction. Resource quota per namespace. So for us, namespace was a team, rather a GitHub org for us. So you should have some kind of restrictions on resource quota, and don't start don't make it infinity to start with. So people will spawn left and right, and it's always better to add it later on, the quota added on, rather than having to start with. Also look out for cron jobs. Cron jobs after they are finished sometimes hogs onto the SCD cluster. So if you go through S3, you find so many of those objects still being there after the job has been completed. Always look around for those. Cleanup of Helm upgrade. So if you're using Helm 2.0, okay, everybody's using Helm 2.x. 3.0 doesn't use config maps, but 2.x uses config maps after the upgrades are done. So clean up those. There will be lots of. So for us, it was around for we ran for a cluster for 1 year. It
had for the QA cluster we're talking about 2,000 pods we were running there. We had around 14,000 config maps, and we never looked into it. So we had 14,000 config maps, which was including the config maps of the users who had apps deployed, but Helm was the majority of it. So look around for this. So many of config maps. Also continuous tooling. So Kubernetes provides such a good platform for you to create tools. API is very much extendable, and varieties of ways you can use it. So basically, finally, the developers are a customer. To keep a customer happy, do continuous tooling. One of the tools that I will discuss today is this, which came out of this issue that we were facing. So the architecture that we saw on the previous slide was a push-based model in which we had something called vector pushing something to deploy to the Kubernetes cluster. Now, the thing is, if something goes wrong in the Kubernetes end, users had to come back and reconfigure everything. There were credentials involved and other things also, which needed to be reconfigured again and again once you come back. Every time you come back. So how to get around this? So we thought, why not build a push model, a pull model? So this is what we came up with. We came up with an extension of Helm called Helm syndication. So we started using the Quay registry app. So Quay registry app, what it does is allows you to keep your, so you can upload your Helm charts in a different channels. So this is your Quay registry app. The right side you can see different clusters. Now, leveraging this, what we did is for different channels, we could easily subscribe our app. So once you deploy your app, you don't have to upload your Helm charts again. Rather, what you do is subscribe to a channel which has those charts, and it will pull it from there, rather than you pushing those charts to your Kubernetes environment. So over here, the non-prod is subscribing to the dev and QA. The production is on the subscribing to the stable channel. So rather than you pushing those charts into Kubernetes, what you do is you push them to here, to this repository, and they will be pulled back instead. So how are you doing this? So we are writing something like this. So we wrote a CRW called authentication, and all it does is very similar to a deployment file. Instead, we have a channel. It subscribes to. So what happens here is, say you have a stable 1.3 version uploaded, a Helm chart of version 1.3 uploaded to the stable channel. So the cluster will go back and pull this from the stable branch instead of you pushing. Now, say you want to release 1.4, all you need to do is in that same stable channel of the app registry, you upload 1.4, and Kubernetes will itself pull it rather than you push it. So this solved a lot of problems for us, and it was widely used within our community. So how does this work? It is very simple. It's a controller that looks for app registry, already deployed things, and if there's a new deployment. If any one of these changes, it updates your deployment. That's it. This is very simple logic. Okay, I have a demo. Let me check whether my VPN is working. Yes.
I have a question.
Yeah.
So, are you using, you guys are using chart for the configuration management as well? Like, if there is a change in the configuration of the product,
Right.
Is it coming from the Helm chart?
It is from the Helm chart.
That will also act as a release and
Right.
all the configuration. Right.
So what this does is, instead of you pushing those Helm charts to Kubernetes, we push it to the registry. Okay. Okay, I will come back to this. I'll complete my slide. Come back to this if I get time. I think it's not working. Okay, phase 2. So this was the phase 1 part where we had only 5% of our workload. Then we planned, the next phase was to plan for 100% of it. Something happened in between. So we got this contract. So we got the defense of Department of Defense US contract. So
They spend around $9 billion per year, the highest spender of travel in the world. So this was a huge contract for us, and we wanted to implement this right away. But again, being Department of Defense, there were different compliances that were not put to us currently. Currently, we were looking into GDPR or something which required your data to be present locally within a cluster, within a jurisdiction. This was different. This was more like uh, there was compliances which were more closed. So it doesn't matter whether you host it wherever you can host it wherever you like within the United States, but it should be closed by nature. And very few people will have access to this environment. It was something like he has to be US citizen and has to live there for 10 years. So it cut out most of our employees. So nobody really has access to this environment. So this called out for a lights out deployment, in which without touching the environment, we need to deploy stuff. So, this led to two different stories. One was we had a huge monolith which is currently being broken down into microservices, and we've been prepping up to host those into our own Kubernetes cluster. So moving forward, this is what we what we are doing currently. So instead of those tectonic environment that we saw earlier, we are moving to a conquer-based Kubernetes environment. We call it Kraken inside. We're working with FTO. FTO, anybody knows FTO? Very few people. So, FTO is a Seattle-based company started by two original members of the Kubernetes ecosystem from Google itself. So, one of them, I guess, was a product manager, the other was the lead developer of the Kubernetes original product. So, they started a company called FTO. So, we're partnering with them to build certain tools around this. So, one which I was a part of was called Quartermaster, which will be open source very soon, which takes whatever changes, whatever mutations going on in your objects inside your clusters and puts into a DynamoDB outside or a DB of your choice. So that helps you to get more visibility inside what is happening inside your cluster. Apart from that, we are trying to make a multi-cluster ingress with them around Istio, which will enable us to do more better blue-green deployment on our clusters. So that is one thing that we're working on with them. So these will be open source very soon once we make it. Modern mask will come out very soon. The pipeline should be zero touch. That is what we are aiming for. And everything we are hosting on AWS. So that gives us quite a lot of flexibility, which we actually missed when we were deploying onto VMs. So we do an IAM integration around it so that we can easily access our clusters. We wrote something called Fail, which does an end-to-end testing for a managed service. So how do you know whether your service that we deployed onto a foreign AWS account is working or not? So what we did, we wrote so finally did an API testing because Kubernetes finally API. So this is a finally basic API testing that you wrote. So this is a plug and play kind of a device that you can easily change and modify. Something like a traffic migration tool so that when there is a new cluster coming up, you don't need to worry about, at least the concur players don't need to worry about. We can easily migrate those workloads onto the new environment and make it working. Workload node autoscaling, which is missing because we have VMs. Image whitelisting using Notary, some more enhanced auditing which were required by the DoD project itself. We are trying to deploy the Istio control thing. We'll be replacing the Nginx ingress because of the issues that I mentioned, and we'll be using the Istio ingress instead. This is more aligned than the one that we get as in Nginx ingress. And also 100% of the team will come over. So these are our plans. Istio is required. So we're breaking down the monolith. So if monolith it is saying the right that if the monolith had one problem, microservice will have n number of problems. So what happens is how to communicate between two different monoliths, sorry, two different microservices. Also, how to understand which service failed, because finally we'll hit towards a dead star kind of architecture, where something fails, you need to understand it and pinpoint it right away, rather than debugging that whole 20 plus or 30 plus or 200 plus microservice. So to help in that regard, to get all those metrics, there's something called Istio around. So along with the envoy thing. So you can use. So what we're trying to do is we want to enable that right away, but there are issues with blue-green deployment around it. Because the community is not that matured yet. So trying to contribute back to that. Until then, we want to use the ingress to start with, because Nginx ingress is not the way to go around with our cluster, because it has so many issues with reloading and all. So that is why this.
So what will be used as ingress?
Istio's ingress.
So that's the only resource, right? But from initially deployed.
Right. So underneath it, I guess it uses Nginx itself, but that reload issue is not there, because inherently the logic is quite different from what is used in Nginx ingress. So Nginx ingress is just a controller. It watches for your ingress objects, and if there is a change, it goes back and writes to a Nginx conf file and reloads the whole thing. So which causes this kind of disruptions within your network, which is not present in this case. So that's why we are going forward with this. And also we have smaller clusters, so this will minimize the footprint quite a lot. Right, so this is how we'll be releasing our new cluster. So I talked about this cluster migration issue, right? Cluster lifecycle issue, in which we have multiple versions of cluster, and every time because of the push-based deployment, every time what we needed is to involve every other team which were deployed in the older clusters to come and move to the new cluster. This will go away in the newer clusters. Why? Because once we have a new release, which is the Kraken that we will deploy, and we'll set up a new cluster, and there will be a migrator. This migrator is basically written on FTO's Arc. So, we use the same thing, FTO Arc gives, but we have wrote around it so that it is easier for us to migrate. So yeah, that will be actually it from my side. Let me check if I can start the demo by connecting to a different TV, or maybe this VPN works. Do you have? We have some time. I have.
Yeah, I think we are almost there. 5 minutes.
Okay, let me just try to get to a different VPN. Yeah, I'll just try this. If this doesn't work, I'll take questions. I'm just trying to do VPN so that I can show the demo. If this works, otherwise I'll take questions. Yeah, there's some problem. Okay, I'll take questions now. There's some issue with my VPN.
Yeah. So, what is this in your deployment model is? Where is the security, how the security is playing a role? Because I didn't see any of the vulnerability scans or how are you managing the sanity of the existing pods or images?
Right. So thing is, so as you see the Tectonic managed cluster, right? So they provide us something called Clear, which does a container scanning, and it gives you what CVs you have, what potential risk it might have. So based on that, we provided APIs to the security team, which used to enforce it from outside. The feedback that we got from them is that because, like I said, there was no platform standardization to start with, and we didn't provide any hardened base image. Some teams were smart enough to do it, most teams were not.
and that causes certain issues. So this is how we'll try to mitigate by doing platform standardization and also using Notary as a container whitelisting strategy, so that every content that goes in has a trust from outside. So these are the two things. Third thing that we are trying to do, but not right away, is something called a governance framework around Docker files. So there can be keywords. You can write keywords like you must do this, you shouldn't do this, you may do this kind of things, and enforce those verbs as rules, rule engine somewhere, and then enforce it. Because finally those are some kind of files that you need to read out of GitHub. So and everybody is using them. So you read those files, enforce. Okay, you are not using this, you are not using that. So it should be.
It's only before the deployment, but in phase two, after the deployment, how do you maintain it?
After the deployment,
phase one.
Yeah, this phase one, yeah. So phase two, two, three things. So before deployment, I talked about. After deployment, there's something called runtime detection. If something is running, how to detect it. So you're not thought much about it currently.
Yeah, because that's what I saw.
Right.
Yeah. And also when it comes to PCA and PI standards,
right.
You said US government.
Right.
How are you trying to encrypt all the traffic? I mean, all the traffic has to go to an encrypted place, and then it has to get decrypted there and understand what the how the network packets are like. But I didn't see that in your.
So I guess Istio will provide us if you use the ingress.
No, Istio will not provide.
The CFA standard
will provide circuit breaking and
the ingress has a CFE standard, SPIFFE something, CA standard. So that will provide us. Also, the Docker images will be strict standard to start with. So SPIG, strict compliance will be there. So that will also enforce DoD.
Okay.
Are you using gRPC?
I'll come to you.
That will actually
You had some questions?
No, we talk off.
Okay.
I think that for the what is question you asked, the port-to-port communication which I understood. Is it to provide gRPC? Are you using that?
No, we are not using current, only the ingress part. So cluster entry will be through ingress. Rest will be whatever we are following till now. Services or not console. Mostly Cube DNS will be using. Or Core DNS.
Envoy will also come in the picture.
Sorry?
Envoy will also come in the picture.
Yeah, Envoy will be always there. Because it's still ingress you are using, Envoy will be also.
Port-to-port communication is not secure to me.
Port-to-port, it is, there's something called Istio CA standard, there is called something called CFE that uses, which actually
takes care of this.
Which actually does this.
And this tectonic you are using for what I understood correctly, you are using for the registry server for your images.
So Tectonic is a managed Kubernetes service given by Core. Along with it comes Quay, that is a different package you need to upgrade to, and that is the container registry for you. And Tectonic will be the whole Kubernetes cluster managed for you. And
what is the container registry here?
It is Quay. 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 Quay is the container registry for us.
So there you are using from the edit.
Right.
So we have many projects like Docker Hub, Google, but you went for the
because we were already invested in Tectonic, which is part.
Oh, and that is the
they have
integration with
Any other questions? Very good questions, actually. We have hi.
We had a similar situation where we have.
Can you just speak up?
And the problem what we are facing is you are giving the access to users, right? What is that you are doing to the access?
Right, that's a good question. So in the phase one, what we were doing was we were relying on the GitHub model. So based on the GitHub group, GitHub org, we were setting up namespaces for it. So you needed to add something called a container hosting file inside your org. We had a GitHub, we had a Jenkins build running, which would get that, understand that, okay, this container hosting.yml file is present inside this org. Based on the same name of the org, we'll create a namespace. And that namespace will have only access to only those members who have added to that GitHub console. So outside that, nobody will have access. Based on that, we'll create those RBAC policies in there. So based on the GitHub model, you can go. Any more questions?
The binary repository or something? How exactly?
So yeah, so before Quay, we were using Artifactory inside
for a VM strategy. So we also connected to Artifactory for anybody using any kind of binaries that needs to be uploaded for jars maybe, or even for the CI part at least, not for the Docker. So we can upload to Artifactory. You can also upload.
Always you're downloading from the Docker or something like that?
From Quake. Quake. Always from Quake.
That is also an internal hub.
Yeah, there's a managed service given by CoreOS along with TikTok.
So when it comes to the upgrade, right, from Kubernetes different versions, how are you managing with the auto-scaling tools? I'm just curious to understand your...
Auto-scaling we didn't have.
Oh, you
We didn't have.
in ASG node tools? In the chat?
No.
It's not?
No.
So then it will be...
That was not there previously. In the newer versions we have. We are trying to push this. So yeah, so when we start with a new cluster, we'll have only say 1 or 2 nodes, and then auto scale it as new traffic comes in, as it is used.
So that cannot be auto scale, right? It has to be manual addition.
No. So there is something called Kubernetes Auto Scaler. It is open source. You can use that.
You can auto scale it, but when you upgrade it, for example, you have 2 nodes.
Right.
They are upgraded.
Right.
But when you want auto scale, the new node will not be on the new version, right?
Oh, no. Also, updates are totally different.
Okay, so how are you handling the updates when it comes to...
Are you asking about phase 2? Yeah, I actually had that slide. Okay. Can I share it again? Can I share it again? Or I'll talk to offline.
Yeah.
I'll show it again. Okay. Any more questions? Maybe we have last. Okay. You are good. Any questions? You can talk to me now. Yeah. Thanks. I guess we are out of time. What you can do, I can only get you. Thank you.
Right. Thank you for the excellent talk. It will make my life easy because I'll also be touching some similar points. But my talk is mainly focused on how we can ship microservices so that it can be consumed easily on Kubernetes versus running on Kubernetes right? So, am I audible? So, okay. By the way, before the main topic, there are a lot of stickers. Feel free to grab them during the break. There are a lot of good stickers out here. So this talk is about the best practices and the lessons that we learned in our when we are going through our cloud native journey. And about 2 years back, when I used to attend the meetups, there are 2 questions usually asked. One is who's using Kubernetes and who's using Kubernetes in prod, right? And you'll see different pair of hands being raised. The motivation of this talk is not to ask the same question, but kind of express the pain points behind asking those questions, right? And so yeah, that's one. The second is running or playing with Kubernetes is easy. Running production services on Kubernetes is challenging, but what's even more challenging is supporting paid customers to run your microservices on Kubernetes, right? And the reason is that there are 15 plus Kubernetes variants out there, from managed Kubernetes like GKE to self-hosting like OpenShift, Tectonic, then Canonical has its own flavor, Rancher has its own flavor, SUSE has its own flavor, and there are a lot of companies out there which are coming up with their own flavor of Kubernetes, right? And there are several differences between multiple Kubernetes flavors. So if you're running a microservice on say GKE, like you don't expect the same user experience if you try to run the same stuff on, like say, a Rancher's flavor of Kubernetes, right? So that's the motivation of this talk. Again, like I missed the intro part. So my name is Ankur Shada. I lead the solution development team at JFrog. My team focuses on open source. So we contribute in Helm and Google Graphius project and a couple of other projects. I also work closely with partners and customers to solve new DevOps enabled problems, right? So I get to play a lot with like new tools out there. So this talk is in two phases. In the first phase, we'll talk about like what's the best way to containerize an application, right? And second phase, we'll talk about, given a containerized app, what's the best way to run it on Kubernetes, right? In a way that like it kind of works if like say if you're running on GKE versus EKS and so on and so forth. So this talk is in two phases. And before I talk about the first phase, there's a mindset change required whenever we deploy services on Kubernetes, right? When we used to ship traditional apps, like say RPMs or WAR files, the user post-install, they need to go through a whole ceremony of applying configurations, going through the performance guide, fine-tune those applications, right? Whereas with containers, the same configurations, they are part of my Docker image, directly or indirectly, right? So there's a mindset change required. What's even more complicated is when you start running these containers on Kubernetes, we need to specify compute at a microservice level, right? And configurations and compute, they go hand in hand, right? So for example, if I reduce the timeouts, increase the thread pools, so on and so forth, I need to bump up the compute slightly, right? So the configurations and the compute kind of goes hand in hand. The users were running or deploying, like say at least our services on Kubernetes, they don't expect to make to follow the same ceremony, like go through the performance guide, apply those configurations, apply the fine tuning. They expect, like whenever, like say we are shipping a Helm chart, it should be staging ready, it should be production ready, right? So there's a mindset change. The users are not willing to go through the same ceremony when they were deploying, say, RPMs. It's a totally different mindset, right? So it's important to understand this mindset whenever we start like developing microservices for Kubernetes. So first part, like what's the best way to containerize it, right? So let's take a step back, right? So say, for example, we are shipping the traditional app like RPM, right? The user experiences, user will pick up an OS of their choice, right? Then they'll pick up the tools which were probably blessed by their security and their licensing team, right? And then they'll apply configurations. And finally, I have my app up and running, right? Whereas if we talk about containers, right? One easy way is, okay, let's package everything together and we have a Docker image, right? But is it like really easy? I mean, it only looks easy on the PowerPoint, but in reality, it's very challenging. First thing is, can we package all the tools and ship, right? Like Oracle JDK, can I really ship Oracle JDK and distribute to my customers, right? The answer is no, right? If I'm relying on MySQL, right? Can I ship the JDBC driver as part of my Docker image and ship it to my customers? The answer again is no, because it's a GPL license, right? So these were the challenges that we faced, like way at the beginning. Like, hey, like we can't like just Docker create a Docker image with all of these tools and get away with the lawsuits and the legal and all those issues, right? That was one challenge, right? And I'm going to talk about like how we solved that challenge as well. The second is, what's the best way to containerize an application in a way that it's secure, right? So building a Docker image is easy, but making sure that whatever we are producing is secure is exactly why we need CI/CD pipelines, right? And that's the core of the talk. So my talk is not focused on tooling because we are told like the pitch. So these are the main like fundamentals, right? Irrespective of any tools you use, like I'll talk about like the main like fundamental principles which can be used irrespective of the tools to implement the CI/CD pipeline, right? So the first one is build once, like build the Docker image once, and then promote the same Docker image across multiple phases of your pipeline, right? About 3-4 years back, a lot of people were actually not doing it, right? So they were building Docker images at each and every phase. Like question for anyone, like do you know like what? I mean, of course, like building Docker image at each and every phase is not scalable. but what is the positive? Like why people were building it? Like anyone wants to take a stab at it? Okay. So it's cheaper to build a Docker image at each and every phase because I'm only pulling like an app, right? I'm only pulling like a jar file or an OS package, versus pulling like a bloated image layer across multiple silos of a pipeline, right? So like to have cheaper, faster builds, like a lot of like people they were like building Docker image at each and every phase, but of course like it's not scalable, right? So don't ever do that. So it's important to build once and then promote the same Docker image across like multiple phases of your pipeline. And this is what the promotion looks like, right? So over here, I have a Docker manifest, and it points to a couple of image layers. So at the top, I see multiple tags pointing to this to my manifest, right? And these tags, what it shows is my maturity of the maturity of that Docker image, right? Hey, whether it's dev done, whether it's blessed by QA, right? Whether it's blessed by release managers or security architects, right? So the promotion is pretty much like it. It's important to kind of know the maturity of the binary that you're relying on, right? That's why we do promotions. The second one is double tagging, right? One of the requirements of a good CI/CD system is traceability, right? Given a binary, I need to know where it's coming from, who built it, what are the CI jobs which produce that binary, right? Double tagging can be done to achieve those use cases, right? So what double tagging is whenever we are building a Docker image, you should statically tag a Docker image and dynamically tag as well, right? So a static tag can be like a timestamp or a build number. When back, like before joining JFrog, I was doing release and build management for Oracle. And I have my former colleagues to make sure I'm being honest. So static tags, we were using like say to version beyond artifacts, and it can have like say 5 versions. Like it can have a major version, minor version, batch version, 2 more versions, and at times we even found that like maybe we need 1 more digit to uniquely identify a binary, right? So static tags is something which you can use to uniquely identify a binary, right? Something that you can trace it back. Dynamic tags are equally important, especially with if you're building like base layers in Docker image. What dynamic tag is what's a known good version, right? That's what dynamic tag is. Like latest is one of the abused dynamic tags. Latest 5 is still better. What it means is it's the best version of 5.x, right? And it has all the security updates and so on and so forth. So that's one of the ways to generate and consume Docker images, keeping security aspect in mind, right? And we need to use both, right? We have customers who are aggressive. They will jump on and consume dynamic tags, like, and there are few who are conservative, which makes sense. I mean, it's both have their own space, right? There are customers who want to be like very specific. Okay, like I want this specific Docker image to be deployed, right? Both use cases exist. And whenever we are containerizing an app, we should not think like say whenever we are building like pipelines, whether it's using Jenkins, Travis CI, Circle CI, Amazon Code Build, Google Cloud Build, and so on and so forth. Any tools, right? Whenever we are containerizing an app, we are talking about 3 different release cycles, right? So the first pipeline should be responsible to build an app. It can be RPM, it can be waterfall, NPM. And so I build the app, the scan, the testing. There was a brief mention about scan security. So scanning should be done, the testing should be done, and that's my release criteria, right? Once a release criteria is met, we promote artifacts from staging to the prod repository, or maybe to the next phase, right? And similarly for the base, the second pipeline should be responsible to create the framework layer, right? Or the base layer. Like say for like a traditional Java app, my base layer will include OS and maybe a blessed version of Tomcat, right? And it should also have scanning. It should also have testing in place, right? Say for example, I bump up the Tomcat version, right? Now that pipeline as part of the test, it should test against the last promoted version of the app. Right? I need to make sure that nothing is broken, right? So the second pipeline is responsible to create the framework of the base layer, right? And this is where we need to use dynamic tags as well, right? like, okay, whatever I'm producing is the known good version of, say, 5.x, for example, right? It will have all the security updates and so on and so forth, because it's, again, like, it's easy to build Docker images, it's easy to run Docker images, but it's difficult to continuously build secure Docker images, and it's difficult to like avoid security issues, right? They will be there for sure. Especially with Docker images, I have tons and tons of binaries. I have my OS packages, I have the tools which are required to do some stuff, right? And finally I have my application binaries, right? So I'm dealing with a lot of files. Security is very important. And lastly, the pipeline which like binds the output of the host to containerize an app, right? So in reality, I have 3 different release cycles. So the velocity of, like, say, the first pipeline and third pipeline will be like way high, right? Versus the base layer, right? I won't be like generating, like, say, 1,000 base layers on a day, right? But I may be generating thousands of app and containerized app on the same day, right? So that's why it makes sense to not have like a modular or like a, sorry, not to have a monolith build system, right? It's important to kind of understand, okay, like, kind of break it down, right? And especially in the big companies, these three pipelines, they'll have 3 different stakeholders as well, right? Because, like, say if I'm just the app developer, I belong to Docker, right? I'm not the right person to build a Docker image. Maybe I don't know how to write a Docker file. And we'll briefly touching this topic as well. So this is what it looks like, right? So at step 1, I have my code in Git. Then I build all these apps, right? And then I construct my base layer. And how I containerize my app is like I consume all the layers which are part of my base or framework layer, and the new layer gets added, which includes my app, right? This looks simple, but in reality, like, you're dealing with a lot of layers. Right? And I was thinking to do a demo, but like I said, okay, like, let me like make the scripts open source. So this is the GitHub URL, which can be used to, like, where we have examples of this 3-step process, right? And feel free, like, to use to file issues, submit pull requests when we are willing to collaborate and work together, right? Then the approach is to build a Docker image, right? Like I briefly touched about this topic. One way to build a Docker image is using a Docker file, right? But it may not be scalable, right? There are new techniques which were developed. Like, some were developed like 2 years, 3 years back, but not known. And the last one was pretty active in like last 1.5 years, right? So with Dockerfile approach, the problem which I briefly touched is, like, it really depends upon my size of the Docker image, depends upon how I'm writing the Dockerfile, right? When I started, right, my first Dockerfile, what I wrote, it produced like 750 MB. Right? It was a simple, like a Groovy script, and I'm like, hey, like, it doesn't make sense, right? Then I optimized it and I reduced the size to like 150 MB, right? But it's very hard to expect that, okay, everyone should learn Dockerfile, right? I'm an app developer, like, I don't care about Docker, right? Make my life easy, right? So and especially when if I write Dockerfile incorrectly, the number of layers between the two, say, version of the Docker image, it can be huge, right? If it's huge, that means I have not written Dockerfile correctly, right? The size of the layers as well, like, say, for example, if I'm not cleaning up the cache, right, I'll have bloated image layers, right? For an app, like, I don't care, like, it's not my problem to solve, right? So these are the issues with the Dockerfile approach, right? Again, like, I'm a developer, do I really need to know Docker to test and containerize that, right? My ops team is deploying a containerized version of the app which I wrote, right? And I don't need to learn, like, say, Docker. I mean, we should learn, but like, there are always those scenarios, right? So then the question is, how do I build a Docker image without a Docker file, right? And I'll do a demo as well of this. So there is a tool developed by OpenShift, source to image, right? It's a very simple tool, like, and that's why I usually talk about the specific tool, because it's very simple, right? And I'll run some similar command over here. So you say S2I build, you specify a GitHub URL, right? And this URL won't have a Docker file. Then you specify a builder image, right? And it will produce a containerized app towards the end. As an end user, there is no Docker file involved. Like I'm not dealing with Docker file, but I can use a builder image, which I don't need to know. Just specify, just copy paste this, and it will produce me a Docker image, right? So I'll do a demo. So like in this case, what I did is, so we acquired a company for Conan, like what Maven is for Java. Similarly, Conan is for C++. So what I did is I wrote like a builder image, which can be used not only to containerize the C++ application, but even modularize the build approach, right? I don't need to build, like say, if my C++ project is relying on OpenSSL and stuff, I don't need to recompile all my third-party dependencies, right? So the build time will reduce like by crazy, right? And actually, yeah. And before I talk about this slide, let me do a demo. It's all empty here. Let me go to this GitHub project just to make sure that there is no Docker file. And I'll explain like what's the magic going on as well. So this is a simple C++ application, right? There is no Docker file over here, right? And CPP file, build files, and so on and so forth. And if I run this command, what's going on is I say S2I build, I specify my GitHub URL, I specify a builder image, which I'll talk about, which is what this is part of the slide. And then it will produce this Docker image, right? So let me run this command. So it's downloading all the apps from another product called Bitrate. It's downloading all the dependencies, the application dependencies, and it's going to do is it's going to build the app, right? And it's going to containerize the app at the same time, right? And there is no Docker file involved. Wait.
How do we specify instructions? That's what we fine. But
when you go to some complex application, we need to do a lot of stuff by hand.
Yes. So the good part, yeah. So the good part is there are already like, so I had to write like a builder image for C++ because it didn't exist, right? There are a lot of community builder images being developed by Red Hat itself, right? And like there is one for NPM, Go as well. The Go one is, I believe, 1.10 compatible. It's not 1.11. It's not like talking about the Go modules yet, right? And there is one for Java, NPM. There are a lot of community builder images out there. And since one didn't exist for C++, I just wrote one, right? And Red Hat also published, like when I wrote something, and they are also publishing the same solution as well.
So basically, we have those what is called builder images.
Yes.
We can go with.
Exactly. Yes.
Otherwise, we have to take the previous approach of having a doc.
Yes, and yes, that's right. And it's very easy to write this builder image. What I've done is the following slide, the next slide, it has source code as well. Like so, whatever we do, it's all open source. And when you look at the source, you say, hey, like it's damn easy, right? It's nothing complicated. So again, like what it did is it built my Docker image, right? So if I do a Docker run, it's running my C++ application. So it knows how to run my application as well, right? And now let me talk about the magic, like what really happens. I mean, I love the like simple tools. So the source to image, it follows a convention-based approach, right? So what happens is on the left, I have my builder image, right? It's a simple image. There's no magic out there. There's a manifest file which points to a couple of image layers. It will have an OS. It will have a lot of layers, right? And it has two files. One is called assemble, and second is run, right? Assemble is a build script, right? Like for Maven, it's going to call like Maven clean install, for example, right? For C++, it's going to call those specific commands, right? And so on and so forth. And the run script is, okay, like, given if I have containerized an app, what is my entry point, right? So the builder images, it includes the assemble file and the run file, right? Usually, like say for different packages like Maven and all these build tools, it's the same flavor, like it's the same, like to build a Maven package, it's only Maven theme install, right? There is no other magic command out there, right? If there is, then create another builder image, right? So what happened behind the scenes is it ran the builder image, right? And well, no, let me step back a bit. So the builder image ran, it did a git clone, right, to a specific folder. The assemble script, it knows that, hey, this source exists in a certain folder and I need to compile and create my output binary, right? And what happens behind the scenes is this specific app, along with the run script, is my added layer, right? So the layer over here, it will include the executable file and the run script, right? And this is my document, right? So it's very like interesting, very easy tool,
What about the environment files, environment variables, as well as some script? Let's say we have to copy it and we have to run it inside.
So yes, that's a good. So we like, so what? Let me see if I can flip this. So this is the actual code, and the environment variables can be specified. Like when I showed like simple version, and like in my case, okay, like I don't have access to internet, right? My source of truth, like in this case, is only Artifactory, and what I'm doing is I'm passing the environment variables over here, right?
While running the command.
Yes. Okay. And again, this is all open source. It's literally very easy. I mean, it sounds complicated. So this is the Docker file of the builder image. To an end user, I don't get, like, I don't even have access to, say, to the source code. And these are the management files. So there is an example which says, okay, like, what's the best way to build this app, right? And again, it's one way to standardize, like, especially if I have like say like more than 1,000 employees and I want to kind of I want to standardize the way I'm building and containerizing the app. This is a very good example, right?
So one thing, like a final image, will it contain only runtime?
That's a very good question. The initial version of source to image, it creates like a bloated version. So it will also include the build file as well, right? But they developed a new technique, like something similar to the Docker multi-build step, right? Where you specify that, hey, I want to copy only like these specific files, and this is my base layer, right? So that part, at least like 6 months back, I checked. The documentation was not good, right? And otherwise I would have shown that, right? I haven't checked if they improved their documentation, right? But something like this exists. So by default, it's going to have a bloated image, right? But they do have a solution to like separate the build part and the deployment part as well. Yeah, that's a good question.
Is the compiler version configured?
Yes. So it depends. Like let me show you. So the compiler version. So in this case, this is the Docker file of the builder image, right? Over here, I'm specifying like what are my dependencies, right? So like say for Maven, if I need to create, I mean, there's already something exists for Maven, right? And by the way, these are secure. These are all like CentOS based, right? So it's like secure. Secure, like the Red Hat, they kind of enforce nice policies. Like I can't just like run it open as root. I need to specify a specific user. So to answer your question, like say if I'm writing this for Maven, right? And if for some reason, if the community image is not good, I can specify the specific version of Maven that I want to copy over here, right? This is one way to kind of enforce standardization across the board.
Is there any dependency on the Docker? I think this uses the Docker daemon.
Sorry?
This code uses the Docker daemon.
I didn't get it.
I mean, it doesn't, I mean, it's a Docker less, but I mean, it's used a Docker daemon.
Yeah, this one is using Docker daemon. So now I'll talk about what ways can be used to avoid Docker daemon.
Okay. My specific thing is Is depends on the person.
Yes, it depends upon the Docker version installed as well. And that's a good, that's the next, so again, like, swing up back, so this is the GitHub URL, yeah.
How has been the experience, like, you guys have gone and either these two facilities? So how was the experience? Like, one is, I'm thinking like, there is a DevOps where they're forcing people to learn more about operations, but now there's a style where you're saying let's abstract everything. And one problem with abstraction is the easy examples were fine, demos were fine, but in the production is a real challenge. And you need some expert to understand Docker file and Docker everything.
Yes, so what the tool did is they said, okay, there are application developers, right? And not all application developers, they need to know Docker to run the flavor of containerized app, right? Whereas the ops team, they still need to know Docker, right? Because that's where the troubleshooting happens, right? But without these tools, the expectation is, okay, everyone needs to know Docker, so that's one difference. The other is it kind of enforces a nice standardization practice as well, right? Like one thing which I learned about Maven is it enforces a lot of conventions. So you're forced to follow like certain things, right? It's very easy to kind of go take the backdoor route and hack few things up, right? But if there are conventions in place, like you'll fix the problem at the beginning and not delegate towards the end, right? So, and again, like this is all open source, and Red Hat also like published this blog as well. So, it will explain like what happens behind the scenes. The next thing is, especially like on Kubernetes, like how can I build a Docker image in a secure environment?
You told off still and need to know about the Docker file. So when app developer is using this tool, he producing corresponding Docker file as well, so that
No. So it was like I answered that question. If you don't have this tool, right? So the app, the ops folks, they are expected. I mean, if they are running containers, they better go Docker.
In this tool, is there also use to
No. So if ops, they can use to standardize their practices, but this is the role of the build folks, right? The build folks.
I will create some image and offload.
So the application developers, they can easily use this tool to test their containerized version of the app, right? Say for example, I'm on my ID, right? I developed an app, right?
Okay, you might have my own development, feature development, you can use this tool.
Yes.
And later it should be used by the Docker file.
It's optional. So it should be that hey, like you should go this way, right? Like build folks can use this tool to simplify their problems. The DevOps team can also use the same tool to simplify the problem. It all depends upon what is my pain point, right? If this tool is solving that pain point, then yes. If this tool is not solving the pain point, then we are wasting the time, right? So it depends upon the pain, like what pain we are solving. Then the thing is, what's the best way to build a Docker image in a secure way, right? Which is without using Docker daemon. Okay? And the thing is, so Docker daemon problem is it's a big monolith, right? You use a Docker daemon to log in, to pull, push, build, right? And accessing Docker daemon, like say if I'm mounting sockets, what I'm doing is I'm punching a security hole, right? And I don't need to have higher privileges just to build my Docker image, right? Especially on Kubernetes, right? It's a pain, like say to configure Jenkins, to expose mount points, and here it's more like, okay, you go to a website, they make you sign the agreement, and you lose all of your rights. So it's something similar like that, right? It's a bad practice to kind of expose the mount points and rely on Docker daemon to build your Docker images, especially on Kubernetes, right? So there are tools being developed by Google. We don't use those tools yet in production, but it's good to know what's coming up in the community, right? And so there's a tool called, there are a lot of tools actually, there's Build, IMG, This Canico is a new one developed by Google. What it does is it continuously takes snapshot of a file system and build the final Docker image, right? So you can use this tool. There's no Docker, like don't even install Docker, right? There is no say Docker even running. I think the client is still required. I haven't played with this tool myself, but I know this team, right? And like via Slack and all that conversation. So you can build a Docker image without having Docker even. And again, like as I mentioned, we ourselves are not using it in production yet, but it's important to know that hey, these tools are coming up, right? Maybe a year down the line they'll be there, or hopefully some before. So the second phase of the talk is like how can we build microservices in a way so that it's easily consumable in across multiple Kubernetes flavors, right? Like when we started, like we asked questions like, okay, like this microservice, what is the core responsibility, right? What's the single main focus point of this microservice? And what are the things it's doing, right? For example, if my microservice, this container also has logic to bootstrap the database, or wait logic to check the case my database up and running, right? Typically the things which were done by scripting, right? If we are doing it all as part of the microservice, then it's like okay, you have a monolith out there, right? So the key thing is to identify common feature sets across all of your microservices, right? And create a separate service, right? And Kubernetes, like one of the reasons why it needs to be done is because like there are a few things where you need higher privileges, but ideally to run your microservice, the same microservice which has a very specific purpose, it doesn't need like higher privileges, right? So figure out ways of like how, like kind of touching your point as well, is like how you can separate like the build part and the runtime part as well, right? If less files I have, if I have a single focus in runtime, right? Most likely I do need high privileges to run my application, right? So identify these common feature sets, identify how you can run your microservice with reduced privileges, right? So that's the key thing. And Kubernetes provides a lot of solutions, right? So once you have identified it, you can use init containers, you can use sidecar pattern. There's a nice white paper done written by Brendan Burns 2 years back, like when I was struggling with writing OpenShift YAMLs. Going through this paper solved a lot of my problems, right? So like one of the use cases of sidecar pattern is like you can have like another container running on a pod, which is responsible to just like pull the logs and push it to the streaming service. So I mean there are like a couple of examples out there. The last is the readiness and the liveness probe, right? It's very important to implement these things. So readiness, like liveness is okay, I'm up. Readiness is like, hey, okay, I'm up, I had my caffeine and I can finally work, right? So it's very important to run this. And one of the hard ways or lessons that we learned, even using this readiness and liveness probes, right? So when we wrote our helm charts, we had some default timeouts and we tested on GT that hey, like it's good. But same helm charts, the customers deployed on-prem, those timer values, it's like it needs to be way higher, like say from 2 milliseconds. Say versus on GT, I need to bump it up to like 8 seconds, right? Because for some reason that on-prem cluster is slow, right? So even like something simple, like you would even think that hey, like I need to worry about this specific thing to support multiple flavors of Kubernetes, right?
More about readiness and liveness.
Sorry?
Readiness and liveness. What is readiness and liveness?
So liveness probe is more like you specify, you expose an endpoint, right? Like say if you're getting 200 OK, that means the service is up, right? It's up, but it's not ready to accept traffic yet, right? And let me think of a good example. Like in one thing, like say we have a product called X-Ray, it has a bunch of like 9 microservices. So like one of my microservices is up, right? But to be able to access traffic, I need to make sure that my database is up and accepting connections, right? So that's why it's very important to have to expose to different endpoints to have those checks in place, right? If these checks are bad, right, or if it's not implemented correctly, it will result in pod restarts. Like something simple as well, like you need to think it through, especially if you're supporting, if you want your services to run on multiple flavors of Kubernetes, right?
So how the Kubernetes help in this readiness?
Sorry?
How the Kubernetes help in readiness?
So Kubernetes, what it did is it said that, hey, like whatever application I'm deploying, right, needs to have these things in place. So it's so in the YAMLs, like say whether I'm doing deployment or stateful sets and stuff, right? Like when we write those YAMLs, we specify what is my desired state, right? And as part of my desired state, they said that okay, like it's a good practice to add readiness and liveness for the service as well. So it kind of gives you guidelines that like what it really means to run a microservice on Kubernetes. Like without this thing, like don't even like bother to run. You can run, but it's not production ready, right? So it's very important to have these things in place. So once we do all this stuff, a single like container will look something like this complicated, right? So over here I have one pod, my main container, which is a single specific purpose of that microservice. Then I can have multiple like helper containers, multiple init containers. Like we are using init containers to wait just to make sure like hey, my third-party service is up, right? And there are like a lot of other examples. Like we solved that JDBC driver issue using init containers. So before my main container is up, we copy the driver and make it part of the same PV, right? And that's how we solve the driver problem. I need to rush now because I got like a 5 in the morning. These are all the best practices. Most of it was touched in the previous talk. I'll specifically point to two things. One is modularize your configuration. Don't expect your customers to go through the values.yaml file, right? If they do, they'll have a lot of questions. What should be done is, and again, like this is something that we are also doing, right? It's not like I'm saying one and like giving hypothetical examples. So the single values.yaml, it includes a lot of key value pairs, and also ship like modular specific files which customers will need to modify when they're deploying on staking or prod, right? Like for example, expose only like say the file which customers will modify to bump up their GMX value, right? For example, so I mean modularize your configuration files. Like don't expect customers to go through a single values.yaml file. It's going to be painful for you. The second is chaos testing. Don't release your app to run on Kubernetes without chaos testing, right? Especially if your application has stickiness with IP addresses, right? It's very important to add chaos, and there are a lot of tools out there to kind of add chaos in Kubernetes cluster and just to make sure that your service is up. We actually fixed a lot of it. We thought that okay, like it's good when we did chaos testing. We found a lot of problems, not only in our services but even in third-party services like RabbitMQ. How RabbitMQ stores messages is that data is namespaced based on IP address. So even if you are persisting data, if your RabbitMQ pod restarts, you lose the data, even though it exists on the disk, because it will create a new folder with the new IP, and that's when it's going to store the messages, right? They solved the problem, but 2 years back, these were the pain points that we dealt with early on. I'll skip this. I'll assume like everyone knows what deployment stateful sets is. These are the ways to like once I have containerized app, I need to pick the right kind of object to deploy my microservice on Kubernetes, right? And got 2 more slides. Good. My PowerPoint crashed. Yeah, this one.
Specifically, any specific tools they use in their own.
So there are a lot of tools. There is a good one from Bloomberg. What it does is it only doesn't add chaos at the pod level. It's also at a node level. Like say, for example, if you have a cluster on Amazon, it will even kill your EC2 nodes as well, right? So it's a very good one. We have our own flavor of it. we are talking about updates and it's like I can't trust this stuff. There's KubeMonkey. There are a lot of tools out there, and it's easy to write one as well. Okay, I'll run quick. So let's say we did all the stuff. We wrote all the YAMLs, right? And this is the last portion of the slide. So we did all the stuff, right? And there are still challenges, right? So there are challenges like throughout this process, right? Challenges without help is we need to write a wrapper script, right? If I created a lot of microservices, like when it's combined, it's a single application as well, right? So I need like some way to specify that, hey, this is my context, right? So there is a need to write a wrapper script which will call like all the kube control create commands, OOC create commands, do the lifecycle as well, like expose options to install, upgrade, rollback, and so on, delete, so on and so forth. Without help, there's no dependency management, lack of conventions. Especially when we are consuming third-party services, there are no conventions at all, which kind of makes it really challenging. You can't add logic, no if else in the Kubernetes YAMLs, but with Helm, it takes care of all the issues. Right? So there's no need to write a wrapper script. Use Helm CLI. There is a context which is release dependency management subcharts. I can directly consume like a chart, say for MongoDB or RabbitMQ and so on and so forth. There's Go templating as well, and it kind of enforces standard as well. And if you want to create your own, there are starters which can be used to enforce your own standards. I'll skip this. I'll skip this. Last slide. So whenever you're building your Helm charts, the Kubernetes vendors they vary on storage and network, right? Support all network options. Support even load code as well. Typically, when a customer they start their Kubernetes deployments, they don't have load balancer in place, right? So it's very important to support all options. Support load code, load balancer, ingress, and it's up to the user to decide which is the right one to pick, right? Similarly, storage, right? So we saw like a lot of charts. They follow the same conventions, right? So like persistent or enable, expose the same value. If it's set to true, you're gonna have persistence. False, no, right? And allow like dynamic provisioning and static provisioning as well. There are a lot of good use cases of static provisioning. We actually implemented static provisioning, but when we moved to stateful sets, we were like, okay, like let's not care about static provisioning, but we were wrong, so we implemented it back again. And it's very important, like when you're building your Helm charts, always allow like to specify a custom storage class, right? That's the variation across multiple Kubernetes flavors. And I think this is fine. I'm done. All right. Thank you. There are stickers here, good stickers, feel free to grab.
So yeah, so we take a break now. After the break, there's the tea coffee there, and we have snacks. And the washroom is in the middle room there. To start at 11.
Yeah.
Guys, there is some snacks here. There's a box here of white ones. People will take it, right? So whenever you have your file here, next one now, we can come down and yeah, whatever you want, we can they are that's it, right? Send the address. Give me a second. Today is 70. Give me a call anytime. Not much, I am going to flight. So I'll be there. Then I'll be there in Q4. Get you get one man. China and Malaysia.
Guys, so let's get settled. I think people have been quickly so we can start and get time. What's that? Just a second.
Yeah, Renu ma'am, can I call you sometime? In an hour. Thank you. I'll do that.
Request Atul from Kubernetes to come and speak about what Kubernetes does in general, and then go.
Thanks. Hi. Hello folks, I'm Atul. I'm an engineering manager at Kubernetes. I've been here for about 6 months now. And I'll spend a couple of minutes talking about what Rubrik does, and then you can ask me later if you want to know. So Rubrik delivers a single platform for data protection and management for enterprises in the cloud, on the edge, and within premises. Enterprises use Rubrik because it helps them simplify backup and recovery. It helps them automate, get a lot of automation done, and accelerate their migration to the cloud. Rubrik was established in about 5 years back, and we have been shipping our product for about 3 years now. We recently hit an annual revenue run rate of $300 million. So Rubrik was named the best of show at VMworld 2 years in a row now, and also one of the top 10 startups. I got into the LinkedIn's top 10 startups list. Again, we are in that list 2 years in a row. We guys at about 80 engineers here in Bangalore, and headquartered in Palo Alto. We have a total of maybe 250 engineers at this time. We are looking for talented software developers, QA engineers, as well as DevOps engineers. So feel free to reach out to me. I'll hang around after the talks, or if you just want to know more about how to bring helps enterprises.
Thank you. So now let's head to the next talk, which we have covering CI/CD with service mesh. I just have a few slides. Before that, I just mention about what you're going to do. Before I talk about myself, my name is Deepak. You might know that I'm kind of following the local meetup group. I run a company called Cloud Yoga, and we provide consulting and training around containers. So what we're going to do today is we have this application which we have deployed on one of the Kubernetes cluster there. So this application is currently in the production stage. What you see here, this what you see is Cloud Yoga prod something, right? Just keep a note on this particular thing, prod staging or on beta prod, something like this. This is how you kind of see there. And what we have also here is an interface. It comes clearly there, but let me see if I can. Yeah. So here is I have deployed Istio, which is a service mesh. I talk about that one. But what you're seeing here is look at this particular green thing here. It's 100%. So what's happening is I'm currently running a curl script, curl while loop there. It's not there actually. Just let me run it. So with this, we are hitting that particular IP address, and
That's what we see here. So if you kind of do that, we'll see activity happening here, and that's what we see here. It's like there is some graphs going up and down, and all the traffic is currently going to my production URL here, right? And let's talk about a bit on this app also. What this app consists of. This app consists of front end, which I showed you there, which is the front end of that, and then we have a backend which is associated with the same front end application. This contains so this is the code for that. So here is the code, which kind of, if you kind of look at. So here is the code I have, using which we are communicating with the MongoDB database in the backend. So we have a front end application which has a MongoDB running behind the scene, and we communicate with this backend application, which kind of go and sits the hit there, and then we save the content there. So what's happening is, whenever you write an entry here, this entry is getting into your MongoDB database, right? That's one thing. And one last thing I'll talk about. We have deployed Spinnaker here. Spinnaker is a CD tool from Netflix. So I'll kind of quickly show the CI/CD pipeline of that. But what we have is Spinnaker, which is going to your CD store, and we'll deploy in Kubernetes environment on top of that, which is serving that application what we saw there, right? So what we are going to do now is we have this application which is currently being served only in the production stage only. Once we run the pipeline, we're going to do you can think of a parallel production environment in which we put some node and you can see that one. So hopefully this makes sense. I don't have much slide. But what I'm doing right now is, I'm not sure how many of you are following that one. So there is a DigitalOcean, I'm doing a DigitalOcean webinar series. Let me just go that one. Can you hear the sound? CICD. So because I was trying to build a lot of, I was trying to work on the slide, but could not do it because of lack of time, because we are working on the demo part. But there's a webinar series which I'm doing with DigitalOcean right now, which covers CI/CD with containers. In this kind of, we have a next session coming up week after this, 24th, it is around here. And that you'll find a slide how to configure Spinnaker and all those stuff. So just kind of assume that is being set up right now. But you can wait for some time where you can watch this video slide and everything would come there. So what I'll talk about is Istio for a few minutes, and then we'll look at our safety pipeline and then how it kind of works all together. So generally what we do is we communicate with these services, assume that you are running a payment service and an order service or whatever, you just said it works. But what might happen is your payment is on maybe different cluster or and your order is different customer. So, but we assume that's direct communication there, right? But that's not true. There's always be something in the middle, using which you're going to reach to a different service, right? That's how we generally do. There are multiple hops, but our assumption this, everything happens directly. But in between, you have networks, you have network fail, you have router go down, and all those things. So how does these kind of problems can be handled in a graceful manner? Right. So the kind of problems what you're going to see right now is, for example, deploy this application on cloud native environment. You will see how can I discover my service which are in different cluster. How would I do retries? For example, if I fail for first time, for example, if I'm doing a payment service, if the payment failed for some first time, can I do a retry in 2 seconds after that or not? How can I handle timeouts? How can I handle load balancing? These kind of problems would come when you go towards your microservices on the cloud environment, which I have covered briefly also in the sessions. So to kind of overcome that, Netflix came up with these open source tools a few years back, which kind of does specific stuff. For example, this Histrix would do circuit breaking there. You would have Eureka for discovery and so on. But what they did is they did it just for the specific application called Java. So they built these tools only for Java, so that when you're doing these retries or those kind of stuff, they all baked into that Java runtime or whatever they call it. But they're specific for Java only. So this is how you kind of getting these tools, which is coming into your whatever you see right. This autonomous that kind of being baked into that particular application itself. But what's going to happen is we're not going to run the same Java application all the time, right? Now we are going towards Python, whatever languages you have, and not necessarily each of the component would be of same language. You might say, I would write my payment in Go because it's much more faster. But I write my front end in Java, right? Those kind of things would come. So how do we handle those kind of scenarios? And for that to happen, what we could do is we could have a proxy or kind of say management tool which could handle all of those things. So rather than putting everything into one single Java application specific stuff, how about we take out that particular feature set what we're looking for outside the application thing or outside the specific language. So what we have come up with a proxy. The proxy would handle those features claims. What I was talking about earlier, right? All of these features or the circuit breaking, edge router, or whatever those things are there. Right? So instead of writing those things only for a specific language, how about we build them for everyone? That's what particular proxy is about. Right? We're putting everything in the proxy. Proxy has all those functionality. So what we're saying is, with each service or each pod, you can see Kubernetes, we're going to attach a proxy, which has that kind of logic there. So other than having your application programmer to write the code for circuit breaking, write the code for timeouts, we don't kind of focus or kind of force our developer to do that. The developer writes just the logic for the application, and all of that thing what we talked about can be handled by this proxy. This proxy becomes a mediator between as external client and the main application. But this proxy understands how can I handle timeouts from the retries and that kind of stuff. And this proxy is nothing but Envoy here, but it can be there are different softwares available which can do this thing. Envoy is one of them. So Envoy can handle those kind of problems what we talked about earlier. And we communicate with the external world via this proxy. So we put our service along with proxy, and all the communication is going to happen via that proxy in between. So Envoy has these features, a lot more in detail, but think about whatever we discussed, retries, your filters, for example, you want to say that, okay, if somebody is logging in from iPhone, I would charge him more. If somebody is logging from Android, I'll give him less pricing. Those kind of things you can do, it already happens to you, right? So those kind of things there. So basically you kind of have a guy who kind of looks at your headers or whatever request you're sending. For example, you can save a request coming to my application from India. I would forward him to this particular server. Similarly, for US, I'll forward different things. So all of those things, logic can be built with this Envoy. You also collect all these metrics, data, and everything with this thing.
You were telling that. You were telling that the environment take care of the intent of the whatever the service or code we talking to, right? Like the circuit breaking.
Yes.
Communicating.
Yes, that's all taken care by this.
The basic question comes that when your container wants to just keep the container want to document directly to it, how the proxy will come in the.
Yeah, so what happens? This proxy gets seamlessly integrated with your application. So there's something called sidecar pattern, which I think we heard about in the last session. Sidecar container gets built into your application. So when you're deploying your application code, automatically we deploy another container along with it. So if you know about pod, in the pod, we have IP per pod, not per container.
Yeah.
So once you hit your pod, it goes by the proxy.
But one thing there is the issue who are coding as the IP, there is coming from CNI, and then they will actually send a traffic. It will directly go to CNI, it should come to the proxy and then it should go out.
See, the proxy is sitting inside your pod, Okay, it's not outside. It is with your application. So when you deploy, for example, yes. So we are saying that we're going to deploy that envoy proxy with the application together. So if you have 10 applications, you are running 10 envoy containers along with each of them. What do you have? So we seamlessly get that one. So that puts all the communication would goes via the proxy which is inside that. And now once we have that one, what happens is we can build a mesh around it. So what I'm saying is, let me see if I have a slide which covers that. No. So what we're talking about is now we deploy this proxy in each of your applications. And now because these proxies are running each of the container, we are somehow going to program these proxies dynamically. For example, if I say I have deployed proxy in all of my 10 applications, and now I have a program manager, or think about, talk about that control plane there. Control plane go and say, whenever talk to the backend service, you would include 10 seconds of wait time. So what we're doing is we have a third party sitting outside who is programming that and dynamically as per the request. Right? So that is what we'll talk about here is the environment deployed on each one of them, and once we kind of deploy on all of the applications, we build a mesh around it because it is deployed on every application whatever we deploy, and we can program it as we want them, and we build a mesh around all of these envoy proxies in between. What it gives you resiliency, security, observability, and routing control. I'll come to these points in a very well look at the demo there. Let me just look at this slide and then, yeah. So what we're saying here is here is the STU. So STU is one of service mesh. So we talked about envoy proxy, but the STU is one of the service mesh. There are more of them, but they kind of work on the same logic that you have a pod. Think about the pod service and deploy proxy on each one of them. So you have 10 services, you have 10 applications, and each one contains its proxy. And now we have a control plane here. The control plane is a pilot component. Pilot component would go and program each one of them. Saying this, if you talk between here and here, you will receive 10 second latency. Or you can retry after 5 seconds. When I say, if my backend is not available, I'll go for 2 minutes, 2 seconds wait, I'll try again. That logic is being built into these proxies by the control plane. Other thing is there's a component called site-level. This is TLS proxy or TLS component here. So the communication between them can by default be TLS based. Don't do anything extra there. See, the communication between them can be an open communication within the application, and the proxies can be open communication. But between the proxy to proxy, it would always be secure by this tool called site-level or by the component of it. Make sense? So you have this, within the pod, anybody can reach out to you. That can be a open communication. But whenever they communicate either internally or outside, it goes on the same way. Yeah. And then we have the component called mixer. Mixer would give you telemetry. So every packet or everything, whatever transfer you will make, it would happen by the mixer component. And mixer would kind of know if you have went from back end to front end, front to back end, this is the data what I'm getting. So basically what you see there, right, which I showed you in the graph, or just go back. So this is what I showed you, right? This telemetry is happening because I'm doing the thing all the time. So all the packet is going to the proxy, and this is the component which mixer is being emitting out the telemetry data, saying that you are only hitting the production service right now, which is 100%, completely fine. Right? So it is a very top level overview of STU, but think about it is a communication mechanism which you insert with each one of your applications. I mean, you have option to not to choose it. You don't choose it, but you choose that, it will happen like that. Make sense? Okay, let's go back to the CI/CD thing, and let's look at our pipeline there. Yeah, so here is the pipeline what we have. So what I have did is I have prepared a cluster, and I have configured my pipeline with the application which I showed you. Let's quickly look at if I can show you that one. Okay, so Hopefully this is working. Okay. Anybody use Spinnaker too? I think you would have used. So Spinnaker is one of the tools. Jenkins everybody uses right now. Jenkins can do all the CI work for you. Spinnaker is a tool by which you can do you can include Jenkins with it and you can do complete SD along with it. So what we're going to do now is we have okay. So here is okay, so we have a pipeline being built into this. And what we're doing is we are going to now do a commit into our Git repo which has the code. Once I do that, a Jenkins job gets triggered inside Spinnaker. So we have Jenkins configured inside Spinnaker, which looks at a change. That have you changed your code? If yes, then I'll trigger the pipeline. So I'm going to make a change into my code base, which would trigger a Jenkins job. And once that I build an image, my staging would start deploying. So once I deploy to my staging, with the staging, then I'll have a point where I need to verify that, okay, once I deploy staging, I'll go and check my application, the application works or not. If it works, then I will deploy into my deployment beta. Think about, there's a pilot deployment that I'm going to production. So I will deploy my application there. And then what I would say is, I would say shift the 80% traffic of production by Istio. So my customer does not change any URL per se. So their URL remains same. But what's going to happen now with the help of Istio, I'm going to send 80% of my traffic to the new deployment which I have done. Generally, we will keep it 20%, but to show it, I'm doing 80%. But generally, when you deploy into production, you will say, okay, take 10% in the beginning. So once you deploy that one, then my beta would get the 80% traffic, and then I would go and check. Like, for example, when I would deploy the application, you kind of say, okay, is my app is working fine? So there you have some metrics there. You kind of look at the data. Am I getting the right response time? Am I getting the right latency? All those things, right? All less latency. Once this looks fine, then what I'm going to do is I'm going to deploy my 100% traffic to the new production environment. So whatever I deployed the last one, I'll move my traffic to the newer one. Basically, I'm going to deploy, I'm going to take the image which I have built, put it to production, and production will now have 100% of my traffic. Once my production gets 100% of traffic, I'm going to clean my staging and my beta production environment. Because I don't need to run that again. Because if I have moved to production 100%, why should I keep running the containers in the staging and the beta production environment? Make sense? So we look at the behavior now, and then I'll go there. So here is, hopefully you can still hear me, right? Other than kind of putting the mic there, I could. Okay, so here we have 3 namespaces here, which I want to show you. So here is the Kubernetes cluster we have, and we have currently production, beta production, and staging. And currently I'm running everything in my production environment, everything is there. Now look at my pod, if I see the pods here, the staging environment. So I shouldn't have any pod running, nothing is there. Correct? Similarly, my production beta would also not have any pod running. Correct? Currently I'm running in production, so let's just look at the production data, what I have there. The production I am running one backend, one front end. So I have a front end application which we have shown you, and there's a database application. Correct? And now what I do is when I deploy my application to beta production, I would communicate with the same database. Because my data is still in production, right? What I'm serving is still production. So it's coming from the beta UI, but database still remains same. Right? So when I deploy my application to beta production, I would look at the same database. Make sense? So this is there. So now what I'll do is I'm going to do a commit into my Git repo, which is going to trigger this pipeline. Right? So let's just go ahead and
do a commit into the Git repo there. So here is the front end, and not here, sorry. Yeah, here. So currently, if you look at the way we look at here, if you look at, it talks about name and the email. So I'll just change it to your name and your email in my environment, right? So I'll go and modify this application here. I'll go to my temp. There's a profile file there, so I'll go to the profile templates, profile.html, and I'm going to make a change here. And here is that email, and here is that thing. So I'm going to make it to your name and your email. Fine. So once I do this thing, what's going to happen? Let me just do a commit. And this is going to go and trigger a job in Jenkins, which is watching to my Git repo. Is there a change happening there, right? So hopefully, demo works with us. Yeah, it might take. Yeah, so I think it started now, right? No, it's the old one. Sorry? Yeah, it's every minute. Yeah. Yeah, it's triggered, right? So now you can see this timer is triggering up, and this is going to make a new image on my Docker Hub, right? So you kind of go and look at there. We're going to build a new image, and it's going to build an image and put an image in my Docker account. Once the image gets pushed, what's going to happen is I'm going to see a new my button get triggered. This might take some time in between, so we have to kind of have some patience there. But Spinnaker have different ways of doing it. So let's just wait. So
Kubernetes triggering is also done by the Jenkins only.
Kubernetes triggering. So what's happening here is triggering happening by the Spinnaker tool. The Spinnaker is a tool which understands your namespace.
So Kubernetes just put.
So Kubernetes is for deployment. Kubernetes, all about Kubernetes. Kubernetes is the underlying stuff. What now what is happening is by the Spinnaker tool.
Sorry, my question was that now Jenkins has pushed to the repository.
Yeah.
After Spinnaker coming.
Yeah, Spinnaker would keep us. So basically, we have configured this thing that whenever I see a new image pushed to my Docker Hub, I'm going to trigger my job here. I'm going to trigger my pipeline. So just wait for some time, and you would see a new build got triggered here. Yeah, so it's already triggered 9th one, right? So as you can see, I'm currently in the staging stage, and it is deploying the staging. So once staging is over, it's going to wait for some time. Ask for the manual step, saying that does it look good staging, right? So now if you kind of go back and check our staging namespace there, you will see pods are coming there, right? So you know the staging I deployed a backend and front end, correct? And if I look at the SPC, I think currently our SPC is not in Node Port, but I'm not sure. Yeah, so currently our application is being served on Node Port, but this can be internal also. So what I could do is I could now go to that my cluster's IP and hit my Node Port there. Right. So if I go to the browser and hit my so you would see it's deploying staging, right? Look at this thing. It's in the staging environment. And you can see it says your name and your email. What do you push it, right? This is only in the staging environment. Now let's go, it will wait for us to kind of say, okay, should I go forward? Because I put the manual stage there. Yeah, it's asking now, look fine. So go here and check. Should I continue? Yeah, because it looks fine for me as of now. Let's continue. Now what's going to happen is going to deploy in the production beta, right? So it's now if I go back and look at the production beta pods now, you would see they start coming here, right? So now I have deployed the environment in my beta environment. Now you can see here how many pods I am running. 1. How many containers I am running that? How many containers? 2. One is for my application, one for Istio. What we are saying is, it gets 2 of 2. My application contains only one of the pod, but what happened is Istio has already put one of the sidecar containers there, and that's why it's 2 of 2. Make sense? Now my application is good to go in the beta production. So let me just, now it's asking us, okay, we have done that. Should I shift my traffic? So currently my beta does not take any traffic now. It's always going to my production. Now what I say, move the traffic from production 50% to the beta production. Right? For that, let me quickly show you the rule for that. So let me just drop to my machine. So now I'm logging to my Kubernetes cluster there. So here I would have, so here my 3 rules are there. One is the gateway one, which is the ingress, Istio ingress. So here with the Istio ingress, I'm hitting my application at the node port of what I showed the production one. Now what I have here is 80 beta and 20 production. So what we are saying is now shift the traffic from here. So we are hitting that our host. I'll not go into detail there, but look at here. What we are saying, 80% of traffic should go to the beta and 20% will go to the production. Make sense? So I'm going to apply this rule now with Istio. Again, the command of if it works here as well. Sorry, apply. So now if I go here, a rule will be applied, and now if I look at the application now what you would see in production, you would see beta also. Look at the beta. If I refresh the things, you would now see beta, right? So my 80 is going to the beta, 20 is going to production. And if I look at my Grafana now rule, you would see that there is bottom one also has come here, beta, which is also in the traffic. Correct? So now this looks fine. We can kind of go and check, okay, now beta also looks fine. Now the next step is we go to pipeline again. Yeah, so here is again waiting for us. We applied this thing, okay, it looks fine, let's go. So now what's going to happen is going to now make it looks fine. So now we are going to deploy our now also if you look at here you see in the you see your name, right? But maybe let's see if it works. Yeah, in the production is still the name. Now what we are going to do is changing the applying the new image built in the production environment. So when that happens, let's just go here. Let's go to production now. Like the namespace.
How are you checking that 80% is going to beta?
Yeah, that's what we have this tool there, right? The Grafana tool is there, right? But we're trying it out. And there are a lot of steps you can do here now. So currently the state both are equal, but there are different metrics are there. So if I kind of go and look at the service dashboard, so there are different metrics you can bring out with Istio, by which you can check. I'll not go in detail there, but 80% because we saw that okay, traffic is going there. So look at the metrics in detail to find that out. Okay, but Istio is the one which is going to will be that thing, right? So yeah, what are we in the production now, right? So we'll see. I was showing you. If I say kubectl get pods minus n production. So now you would see that my older pod is getting down now, and the newer pod which just came for the production is running now. Correct? 29 seconds, 1 minute. So now what's happening is our production is going to deploy the older pods with the older image and bring up the newer one. Right? So if I kind of go back and check now, so even my production now would say your name. But still, our rule is still there. Right? So you can say beta pod has your name and also our yeah, but it has gone, it's kind of moved fast. Yeah, now you can look at our production also your name. Make sense? Now, but our still the rule says that 80% to beta, 20 to production. So now what we'll say, we'll move 100 to our production. So we'll go back here again, asking us for doing that. It asks us for it's still waiting for that. So once it asks for that one, we can now go ahead and apply the rule. So we'll wait for that to come. But what's going to do is let me just check in the this is a manual step anyway. So let me just go back and change the rule now. So I'll say production 100%. So now here saying my beta was 0, my production was 100%. Right, so now everything is going in production now. So if I look at, I will always get production only. Right, whatever I'll do, I'm going to production now. So once this is okay, it's got the manual step. I'll just say continue. Now what I'm going to do is go to now destroy the staging and the beta production environment. That I get the clean set there. I'm not running unnecessary pods there, right? So if I kind of go back and now check the pods in staging. Right, so pods are my cleaned up. My production beta would be cleaned up. Right, so it will kind of terminating, it will kind of get cleaned up in some time. So yeah, that's the kind of demo. Any questions here? Correct. Jenkins is inside the Spinnaker. Can the Spinnaker look at?
Instead of writing it outside
the rules, right?
Pipeline of this Spinnaker itself will have the
yeah, correct. So you can have, so basically currently we apply the rules manually there. What you could do is you could write a step in between that can do this route on its own. So for example, currently we have written and applied that issue rules manually, right? That's what you're saying, right? No.
Because I have to go to Jenkins, I have to go to Spinnaker.
So we are not going to
Spinnaker, and the Spinnaker pipeline itself will have a Jenkins.
Correct. I'm not doing Jenkins at all. I just showed you there.
Okay.
I just showed you there.
Sorry.
I showed you there, but they are going to do Jenkins. And here's an automatic job on this thing. It's run inside Jenkins. Jenkins does CI for you. Spinnaker does CD for you.
And those two things come in together.
What we did right, yeah. We did right, yeah.
We can build those steps into this pipeline.
Yeah, of course, why not? Correct. Apply the rules can be done in the pipeline. So whatever we have seen, all of those will be automated in the pipeline itself. It can have, okay, like once this has been done, it would have notification mechanisms. You can send an email to QA guy. Okay, now application staging environment, go and check it out. So all those things possible.
All you do is also running a pod instead of cluster.
Which one's Spinnaker? Yes. Yes. Yeah, it's running in the default namespace. Default name is the Spinnaker. Again, as second step, you can watch the next webinar which I will do next 24th, which will have the steps to set up Spinnaker on those things. Okay, we are good then. Thank you. The ID.
now let's do that. Now let's do this is with yes, what is and Stacy.
My name is Rajan. I work for.
Secret, please. You can secret if you are here. You are on the session today. You can secret.
So my name is Rajan, and I work for a company called Happiest Minds Technology. With me, my colleague Sule, we both work for Happiest Minds Technology. We are part of DevOps group. So today, I wanted to do a session on to the CI/CD using VSTS. So VSTS is a service offered by Microsoft. So how many of you have heard about VSTS? All right. So VSTS is a online collaborative service which helps the customer to do the CI/CD project planning. It's one tool to do everything related to project management. I'll explain you in detail in the next slide. Here we will use Azure Managed Service for the Kubernetes, and then we will use VSTS to do the CI/CD. So quickly. Previously, the cloud service for development. For any developer, if you want to do the code development, they will provide you pre-hosted repositories, and also they provide you a service called pipelines where you can do the CI/CD. They also provide you features like Jira. So basically, where you can do the full project management, where you can do all your creating epics, stories, and all. Those features also provided by VSTS. So it's a one tool where you have everything, your Git repository, you have your CI/CD pipeline where you can create your CI/CD pipeline, you can create your sprints, you can create your testing plans. They have a lot of
test automation tools integrated. So it is one tool where you can do the full collaborative development. Recently, just 2 days back, it's been renamed to Azure DevOps. It's been the Azure's DevOps vision where they want to integrate all these tools into one place. Okay, so my session is full of demo. I'll just give you what I'm trying to show you here. So this is the higher architecture where the developer does the check-in. Can you go to it? All right. So developer does the checking, and once the checking is done, there will be a webhook which will initiate your CI pipeline. And then once CI pipeline is done, I am using here the Azure, the Docker Hub container registry, where I will push my container images, and then I will create a Helm chart, and then I package that Helm chart and push it to JFrog artifactory. So I have my artifact ready in build phase. Once artifactory is ready, the auto trigger will be enabled, which will deploy the your application to the respective environment. So here for the demo, I have created a dev stage and production, where we will show you how this build definition, release definition can be created so easily. So any developer who wants to do the CI/CD and he wants to learn, he can just go to the VSTS and he can create some of the build and release definition, and how VSTS provides these sample templates which you can use it to customize your build and release. So in release definition, we will deploy the code to Azure Kubernetes service. Next. So this is the high level idea where you can see these three processes will be involved in the CI/CD demo from VSTS. So first part where always you need a build agent for any continuous integration. So in our demo, VSTS is providing a free agent where I can use that agent, and they are providing Linux, they are providing Mac, they are providing Windows. All the agents are provided free, and then you can define your build definitions and you can trigger your CI pipeline. And for the testing part, you can enable the continuous testing based on your requirement. And then the release part where you define once my artifacts are ready, you can deploy that artifacts to respective environment. That is what we are going to show you. So just go for the demo. So this is what the base case look like. We will just quickly show you the build and release definitions. So here you can see the build definition where the first part is get resources, where from where you are going to get your code, and the next part you can see here there are tasks available, build image, push image. So these are the tasks which are available by default from the VSTS. So they have created those templates which you can directly use. You don't need to reinvent anything here. You just use these tasks created by VSTS. Just use those and add those tasks, and then proceed with your continuous integration phase. So here you can see the build image. Then once I build the image, I push that image to an Docker Hub. And then if I want to test that image, I will just start the container and run some of the local tests. And then next step is, we have seen this trend where we want to create the Helm packages
And instead of storing the Docker image in registry and pulling those images during the deployment, what we are doing is we are creating the Helm packages, which will have all your Kubernetes manifests, like deployment, services, ingress, all the config, all the manifests will be present there, and we are packaging that and pushing it to JFrog. So JFrog is we are using free version for the demo, but for multiple customers we use enterprise version. And this is the last step where we are just publishing it to Azure. So you can see here there's a simple command to publish it to Helm repository. It is just a one file command where I specify what is my Helm repository and the Helm URL and user response. That's all. And it will be pushed to your So next we will show you the release definition. So this is where it makes so easy for any developer or DevOps engineer to add up this tool. So you can see here, whatever artifacts I have created here, and get those artifacts. So you can link basically your build definition to release definition. So I got all my artifacts. As soon as I get my artifacts, in this case the packages, I want to trigger a build to the development environment. So here what I have defined is, basically we have created, now if I have to deploy it to development environment in a Kubernetes cluster, what I will do basically is I have to have a service account, or I need to have a kube config which will connect from my agent, build agent to the Kubernetes cluster. So we create the VSS gives some amazing feature where you can create these service endpoints, where you can add your service account, Kubernetes service account or Kubernetes config and the server URL. And that way you have, and then also you can add your Docker credentials. So whenever you want to push your Docker image, you usually what you create a full image secrets. That's not the way to do it with VSS. VSS is very simple, where you can create the service accounts and then use those service accounts securely in your build pipeline. That's it.
How does service account work? So service account will have the full secret or secret?
Yeah, so basically in service account what we do is we give either kube config or service in Kubernetes service account, like certificate and then the token, or just copy the kube config and the server URL, and then I refer that in the build.
So you're just doing that from
one
full secret
yeah,
to the Docker.
yeah, that's all. So this is the way where we can achieve the once the continuous integration is done, we can achieve the continuous deployment also in few simple steps. And all the templates have been already given. You just need to use those templates and apply it to your. So this is where we are creating. So let's go and do this. In VSTS, the concept is if you want to build your image, you just need to queue it so that the available free agent, one of the free agent will pick that job and it will start. And one of the advantage of running these jobs with VSTS is you will get full visibility of your logs. Every step you will get full details of logs. If there is any failure, you will get all those details, and then you can integrate with the email, you can integrate with your dashboards, where you can push all those details to in case of failure. So it is just waiting for the jobs. We can, yeah, so it got the agent available agent. But in case of for actual customers, what we do is we just create a agent where the private agent, and one advantage is you can always use the cloud hosted agent, but also you are having on-premise instances. You have a lot of big data centers, a lot of servers are unused, you can use your on-premise servers as an agent. You don't need to be dependent on only cloud. And the way they have done is, you don't need to be dependent on only one cloud provider. You can use the CI/CD feature, and then you can use the Azure, or you can use the Azure, or you can use the Google, or you can use any cloud provider, basically wherever you have hosted your Kubernetes. This is where you can see the logs, the build an image, and then push image.
So in that kind of hybrid model, what's the latency observed in your experience?
So basically, we suggest customer to have the VSDS instance running near to their region. Like if my customer is in US and he is in near East, so we specifically define that US East region, use that. Obviously,
What is the latency observed? 5 milliseconds, 10 milliseconds?
Sorry, I'm not heard. So once the Docker image tested and created, we are just creating the Helm package, and then we are publishing the Helm. So as soon as we do this step, once the Helm chart is published, the release step will be automatically kicked off. So that's what we are trying to do. Is we are trying to enable a true continuous integration deployment for at least development stack. So that way, developers are getting real feedback on their product. So suppose in case of you have some 30-40 microservices also. In that case also, what we do is we create multiple pipelines for them, and then we deploy the Helm packages, and then we give the real feedback on a development. So this is the JFrog artifact where we are storing our Helm packages. So let's go to we can show release. So as soon as the package is created, release will be triggered, and you can see it will go through individual phases, the development, and basically in this case, what we are doing is you can see some of the help needs and help instructions that we are doing because we are using the free agents provided by VSTS. But we can always, when we are having our own agent, we can have all the prerequisite installed like Helm. So all these three stages, basically they are deploying our application to Kubernetes cluster. And we use Helm because it has a lot of advantages where you can do rollback, you can do rolling deployment, a lot of other features with the Helm. And if you have the packages enabled and then you have the versioning enabled on your Helm packages, you can easily roll back whatever version you want. So we will show you some of the tasks here, how easy it is to create these tasks. You can go here and you can select some of the available, by default available tasks, use those tasks, and try to create your individual respective steps. Like in this case, I'm creating a namespace creator, then I'm installing the packages and running some test cases on the developer. So there is always a question where we are creating these tasks manually, but in case of we are having 30-40 microservices, how it's going to scale, right? So VSDS also provides the APIs where you can create the templates and use the APIs to create these build and release definitions. So you can create the same build definition for your individual services. You don't need to create manually. This is for just for demo, but you can use the APIs available from the website to create the build definition. And you can see all these steps in detail and see better. And this is the one part of the VSK. It also provides you, so there is Microsoft provides Visual Studio Code where they do have integration with VSTS. So if developer wants to push their images directly from the VSTS Visual Studio Code, they can do it. And also they added a new feature where if you have just a source code, the plugin will create a Docker file for you. You don't need to create Docker file also. So, a lot of recent new plugins they have added, which is helping developers to quickly get onto the containerizing their application. So, I think this is what at a high level I wanted to show you, how to use the VSTS to do the CI/CD and create your build and release definitions and achieve the true continuous deployment to your Kubernetes environment. Okay, so if you have any questions, you can take it now.
This come as service, right? It's a paid service from Azure. How do you pay?
So this is the yeah. So from Microsoft, it's a paid service, but for open source community, 10 jobs, like 10 parallel jobs, it's free. Like some of the Atom and some of the other open source community projects, they're running on VSTS for free.
JFrog from Factory. That's the free plugin you get.
Sorry?
JFrog. Factory. That plugin you get it free with this.
No, so JFrog it's totally different entity. It's a separate artifact. It's a company. It's an artifactory. So basically, what we do is we create a artifactory JFrog, and then we use JFrog provided URL, and then push our packages. Yeah. So we do have integration, but we didn't use it.
What about Jenkins? Jenkins also.
Yes. So because this provides the release definition, so what you can do is you can use Jenkins to do the build and use the release definition feature of VSTS. So they do have the plugin available for Jenkins.
Those are free and paid.
So this is free for 5 projects, and for open source it is free for 10 projects. And just if you want to try and all 5 projects is free for a small plan. Yeah. The small project is free. But if you are having a lot of projects, it's not free.
What do you provide? So where is the registry for that? That you can use Docker now, right?
Sorry?
Registry you can use Docker now.
You can use any registry. So that's what they have made is one tool you can basically it is not dependent on their cloud provider. So it's not dependent on Azure. You can use Azure services. You can use any cloud provider. And so basically, the argument comes when we have a Jenkins, some of the open source tools, and Microsoft is already invested in the Brigade, where they are creating the CI/CD for Kubernetes, so from scratch. Then why VSTS is having so much popularity in at least enterprise customers? Because what we have seen with our customers is they already have a big huge investment with Azure, and they do get these VSTS subscriptions for free. And then also they are already Microsoft shop, and by default it provides huge plugins for all your .NET, C#, .NET Core, all the plugins available out of box. So it's very easy for them to move and create the CI/CD pipeline. And then they have the project management tool, and then they have the test management tool. Everything is integrated.
How the plugin ecosystem is for non-Microsoft?
Right now it is they are. If you go to the GitHub, they are working on adding a lot of community tools. Like recently, I think they added a support for PRs to GitHub. Anyway, they bought GitHub, but there was no PR support, pull request support, and it was a huge demand. A lot of if you go to see the request, PR request is the highest one, and they added that last week only. So like that, they are continuously contributing the open source community and adding more plugins. And whoever is creating plugins, they are giving free credits to develop plugins. This is where okay. All right. Thank you very much.